Here I am in a scene I made based off of Ditzy Ninja's Godot video on creating a clip map system for a height map terrain. I'll link his video right here. So my next step for my procedural world is biome generation. Biome generation is a pretty abstract subject, so there are virtually infinite ways to generate biomes for your game. For some examples, you could use a Voronoi or a Perlin noise field, similar to Minecraft. There are also other ways, like this ooze method. And then a lot of other games use cells or hexagon grids. So how are we going to generate our biomes? What we can do is generate a biome map that is sampled throughout the world to determine which biomes are where. So that sounds like a pretty complicated task, so let's break it down. How would I go about generating a custom procedural height map? Pretty easy. We will use shaders and sub-viewports to process image data to create a composite image that looks the way we want. The custom height maps will be mostly based on noise textures and basic shader techniques, but the fun is in the way we decide to process all of our image data. So this is the basic idea. We will start off by generating a few basic images we can call terrain masks. We will call them this because they are the initial building blocks we will use to generate our final terrain height map. The goal is to have various types of textures for different types of terrain in different biomes, so we will sample these terrain maps to know which terrain texture to use at any given point in our world. We need a list of actual biomes. I'll draw inspiration from real-life biomes. I want to have climate zones, Arctic, temperate, and tropical. And then each of the climate zones in real life have their own version of the basic types of biomes based on humidity and rainfall in real life. From driest to wettest, there's desert, tundra, grassland, dry forest, rainforest, wetlands, and lakes. Pretty much all the climate zones have these types of biomes. An Arctic climate might have cold Arctic deserts, while a tropical region would have arid, sandy deserts. So now it's time to start working on generating our terrain. Let's make a new script called World Configuration. This will have all our texture sizes for any images we create. And we'll just do class name, World Configuration. Now I'm just going to do the texture sizes for my terrain masks. And I'll just set the texture size for my terrain masks to 1024 pixels. So now if I ever want to have a bigger or smaller texture size, I can just adjust it here. So now we can move on and start working on our terrain masks. I'm still going to show you how to do the temperature map, but I'm not going to use it in my biome generator because applying the temperature map would be the last step in the biome generation algorithm, and we'll probably need to make another video on that. Alright, so let's make a folder called terrain masks. And I'll make another folder, and I'll make another folder called temperature map. I'll also go ahead and make a folder for humidity map and our rainfall map. So we're gonna skip the temperature map this time because we're gonna apply that to our biomes in the next video. So let's start with our rainfall map. Create a new scene. And I will add a margin container and a color rect so that we can see our shader. I'll just set the size to 1024 like before. So now on the color rect, let's go down to material and make a new shader material and a new shader. We'll call it rainfall map. Alright. Make a uniform sampler 2D for our noise texture. And in the fragment shader, we'll set our color to a sample of that noise texture. So now in our shader parameters, let's make a new noise texture and let's add fast noise light to it. And I'll just go ahead and save the fast noise as Rainfall Map noise. Then I'll even save the noise texture as Rainfall Map noise texture. So now I want to make our noise look a little bit more like weather. So I think first I'll increase the frequency a little bit because I want our world to have diverse biomes. And under fractal, I'll set the octaves to like 3. So it's a little bit smoother. And we will make the lacunarity 2.7. Let's see how that looks. Alright, now let's check domain warp. And that kind of looks like some weather patterns. Let's make amplitude 40. And then frequency something like super small, like 0.007. Okay, so that looks pretty good. So now that we have our rainfall map, we want to save the image when the scene is run. So we're going to need a new script to do that. We'll attach it to rainfall map. Just call it rainfallmap.gd. So the way that we're going to save an image in our folder of this noise is by adding in a sub viewport and making our color rect a child of that. And you can see your color rect by clicking on the sub viewport now. By making the color rect a child of the sub viewport, it applies the color rect texture to a viewport texture assigned to the sub viewport. And with this sub viewport, we can basically save whatever shader we end up with on our color rect. So first, in the sub viewport settings, you absolutely need to change the update mode to always and clear mode also to always. And then the last thing we need to do is add a timer to the scene. And set it to something short like 0.2. And we need this timer because if you call getTexture on this sub viewport in the ready function, it executes that getTexture command on a new thread. So if you want to immediately use that texture, you need to wait for that texture to be available. You can either use an await statement, but I'm just using a timer right now. So I'm gonna make references to my sub viewport and my timer. Then let's go ahead and instantiate our world configuration. This will be much more useful later when we add a lot more settings to our world configuration. And then I'll make an empty variable called texture. Because of what I was talking about before, I'll need a global variable to store the texture data so that I can wait for it to be available to use it. So now let's do our ready function. First, I'm going to want to set our texture size. And it takes a vector 2, and we just get our texture size like that. And then we will want to get our texture from the viewport. And then when the texture is available, we will want to save the image. So we'll do that in another function called generate rainfall map. And we will just bind that to the timer's timeout signal. So now I'll just go down here and make that function. Oh yeah, and then back up in the ready function, we'll want to do timer.start so that you actually start the timer. And that reminds me, go back to your timer and make sure you set it to one shot so that it's not saving your image over and over again. Alright, so in the generate rainfall map function, we will want to get our image from our texture by doing var image equals texture.getImage. And this is what would not be available immediately. And then we could just save this image as a Blender image resource, but we want to actually save it as an image texture so that we can plug it into a sampler 2D in our shaders later on. So we'll do var image texture equals image texture class, create from image, and then pass our image to it. And then we'll make our save path, var path equals, and I'll just copy the path right here. And we'll save it as rainfall map.tres. Alright, and then we will save it using the resource saver by passing the image texture to save and its path. And then I'll just print save image. Actually, why don't we go ahead and make a new folder called images that we will use to save all our terrain masks. Alright, so we'll save that. Now let's try running the scene. Alright, saved image. Close this, see what it generated. And look at that, we saved our rainfall map. So now that we have our rainfall map, we're going to want to generate our humidity map. So I'll just make a new scene called humidity map. Do the same thing, we'll add a sub viewport. We will add a color rect. Set the size here to 1024. Set the color rect anchors preset to full rect so that it fills up the whole thing. Then I'll add a timer and we will make it a one shot and set the time to like 0.2. Save it. Go here and make our material, shader material. Let's make a shader. Humidity map.GDShader. Alright, so this is actually going to be the same thing as our rainfall map shader. Uniform, sampler 2D noise, then in fragment, we just set color to our noise value. Alright, so now that we can apply our noise, what I'm actually going to do is duplicate the rainfall map noise and noise textures with Control D, and I'll just change the name to humidity map noise texture, and I'll just move those up to the humidity map folder. And for the humidity map, let's change the seed so it is randomly different from the rainfall map. And in the humidity map noise texture, I just have to make sure I set the noise to our duplicated noise. Okay. And then let me make sure I have my render target update mode in our sub viewport set to always, just like before. And then we should be all set. Let's make our humidity map script. Let's just copy and paste the rainfall map script. Put it in our rainfall map script because everything is the same. And then I'll just change the name. Okay, let's run it and see what we get. Image saved.
And you can see nothing, we didn't get our image. That's because I forgot to add the noise texture to the shader. Now let's run it again. Alright, image saved. And there we go. We have our rainfall map and our humidity map. Alright, so now that we have our terrain masks for our biome generation, let's start working on our biome generator. So what we want our biome generator to output for us is another 2D image like these. That will be our biome map. Visually, you can tell the difference between the biomes by their color, but for the sake of instantiating the right trees or grass in the right parts of the biomes, we will have our generator sample each of the terrain masks for each pixel of the image, and then assign a weight for each possible biome on that pixel. So I'm going to add a scene called Biome Generator. And I'm going to do the thing with the margin container again so we can see it really well while we're working on it. Set the size. I'll add in the sub viewport and timer anyway though. I'll make sure I set update mode to always. Alright. For this color rect, let's add a shader material and new shader. Leave it as biome generator. So now in this shader, let's get uniform sampler 2Ds for both our humidity and rainfall maps. Alright, so the next thing we're going to want to do is define a color to represent each biome. I already went through a color wheel on the web to pick the colors for my biomes, so I'm just going to copy and paste them right here. These are the red, green, and blue values. So a lake is dark blue, swamp is a little bit bluish green, wetlands is light blue, light green, rainforest a vibrant green, yellowish green for dry forest, yellow for grasslands, pinkish for tundra, and then like orange yellow for desert. Alright, so once we have our colors, let's start defining some thresholds for each biome. Since our noise textures for the humidity and rainfall maps are black and white, a sample of each pixel gives us a value between 0 and 1. If we set some thresholds for each biome between 0 and 1, we can divide the terrain into each biome and essentially control the weight of each biome for the whole world. I experimented with a bunch of different threshold values, and these are what worked best for me. I still kind of adjust them around a bit, but these are good defaults to have hard-coded in until you decide what really works for you. Might look a little bit confusing. You can basically see that places with low humidity will have desert, and then wetter areas will be rainforests. But I decided to have it so a rainforest could appear in places of maximum humidity, but a water biome like swamps, lakes, or wetlands would only appear in places where rainfall is above 0.77. And then whichever water biome gets picked is also based on the humidity level there. So now I'm basically going to go through and assign all these minimum and maximum values for each biome to variables. I'm just going to copy and paste them in. So I'm using the same values as in that picture, but you can see for each biome I have a minimum rainfall value, and then a maximum rainfall value, and then a minimum humidity and a maximum humidity. So 0 to 0.22 is desert, 22 to 33 is tundra, 3.3 to 5.5 grasslands and so on. And then everything is between 0 and 7.7 for rainfall until you get to your water biomes, where RF rainfall minimum is 0.77 and rainfall max is 1. And then they have their own humidity minimums and maximums. Wetlands will be anywhere between 0 and 5.5. Swamps 5.5 and 7.7, 7.7 and 1. You can also see that I added in a blend radius, and we're going to use this value to blend our biomes together so that we can use our weighting system. So let's start up our fragment function. And let's sample our rainfall and humidity. So now we have the values of our rainfall and humidity maps. So since we have 8 biomes, we're going to end up with an array called weights with 8 elements. So it'll help us to generate these weights if we make arrays for the biome colors, the minimum and maximum rainfall values, and the minimum and maximum humidity values. So here I have an array called colors with 8 elements, and it has the desert color, tundra, grasslands, dry forest, rainforest, wetlands, swamp, and lake. Now here we have all our rainfall minimums. Here are our rainfall maximums. And then all our minimums for humidity and maximums for humidity. Then after that, we're going to want to add one more array of floats called weights. And we will use this to store our weights. So now we're going to want to basically iterate through these 8 weights with a for loop. So for I equals 0 at first, if I is less than 8, increment I. And I'll make a float value called rainfall weight, and we'll set it to 0 because it's going to accumulate during our calculation. We'll do the same thing for humidity. So now for this element in weights, we will first define what conditions will result in a weight of 0 for this biome. Oops, gotta add int here. So if rainfall is less than minimum rainfall value minus our blend radius, which would mean when rainfall is out of bounds of our minimum with the blend radius applied, or if rainfall is greater than max rainfall plus the blend radius. And then of course we have to include humidity as well. So, or if humidity is less than minimum humidity minus blend radius, or if humidity is greater than max humidity plus blend radius. So if it's out of bounds of all things, weights equals 0. Okay, alright, so else, so basically everything in this else block is if there is some weight being applied. So if rainfall is still less than minimum rainfall, then it is within the blend radius. So RF weight equals, we'll do smooth step function, the minimum RF value minus blend radius with rainfall as the value. There we go. Then the other way around, else if rainfall is above max RF, we do the same thing. Smooth step. else, we're completely within the bounds of that biome. So RF weight equals 1. So now we are literally going to copy this same thing, but for humidity. So there we go. We have our rainfall weight and our humidity weight. And lastly, we combine the rainfall weight and humidity weight by adding them together and dividing by 2, giving us our final weight. So now we need to normalize each of the weights so that they add up to a total weight of 1. I'll make a float total weight. We'll set it to 0. I'll iterate through my weights again. And for each element of weights, I'll add the weight to total weights. So now, if total weight is above 0, then we'll iterate through the weights again, and we'll normalize the weights by dividing them by total weights. This should make all of our weights always add up to 1. So now let's go ahead and calculate our blended color to color our fragment with. Let's set the color to 0, or black at first. Now we'll iterate through the biomes again and add the biome color to blended colors multiplied by the biome weight. This gives us our blended color. Then we'll just set color.rgb to blended color. See what we get. Big blue square, and I think that's because I didn't add my rainfall and humidity maps. Okay, so I meant to use the plus equals down here. There we go. So now you can see our biomes blending together. I can play around with the blending value. So you can see the clear divisions between each biome, and blend radius smooths them out. Still kind of results in these hard transitions between biomes, and that is because of the way I'm blending the weights with the blend radius. So if anyone knows a better formula for that to make it better, please leave a comment below. However, in nature, there aren't always smooth transitions between environments, so I'm fine with it like this. In fact, it actually works out pretty well because it actually avoids some ambiguity between biomes. If they were blended perfectly, we would probably end up with more parts of our map that are pretty evenly weighted across multiple biomes, and would result in an area with a bunch of biomes mashed together. We still might end up with some places like that, but if we keep the blend radius relatively low, it will be minimal, and any of these areas you do find could be a neat little landmark or a special area. In fact, you could go even further and take any areas blended between more than like 2 or 3 biomes and replace the area with something else besides the blended biomes. Just an idea. So now I want to show you how we can adjust these threshold values. So you can see here, we kind of made it so our lakes are pretty small. So right now, if I want to adjust the thresholds, I can use these values, but we have to do some work to make it so one biome's maximum is connected to another biome's minimum and whatnot. So I'll show you what we can do to make it easier to adjust these threshold values to make biomes bigger or smaller very easily, even by code. So let's add some flags as uniform floats so we can adjust the thresholds. So I have a flag for controlling the threshold between desert and tundra, tundra and grassland, grassland and dry forest, rainforest, wetland, swamp, swamp and lake. And And then I have another flag that we can adjust for the threshold between dry biomes and water biomes, which right now is set to 0.77. And I just used the same values that we were using down here. So now we're going to basically be swapping out these values in our minimum and maximum arrays down there with these new uniform variables. So I'm just going to copy and paste the updated arrays. So now colors are the same, these are all the same, but then when you get to the water biomes, we use the rainwater biome flag. For the maximums, it's the other way around, where we use that flag for all these other ones and then leave these the same. Then for humidity, same thing, but we use all the different flags we made. And then we leave wetlands minimum the same because it's 0, and use the flags. And then leave maximum the same, use the flags for all these, and humidity maximum. So now if I go up, these shouldn't do anything. Now I have these flags here, and I can make the water biomes smaller or bigger. I can make swamps bigger, wetlands bigger, smaller, you know, something like that. Now we got some Great Lakes. I could even control these flags with another noise texture, but I'm not even going to get into that right now. So these colors are great, but so far this is only really useful if we wanted to color our terrain for each biome. But so far we have no way to access these biome weights in GDScript from our shader. We need that to be able to know which assets to instantiate and where. So maybe at first you might think we can just save this image of biome colors. The only problem with this is that we have 8 biomes, and for an image we would only have 4 color channels to use for biome weight data, RGB and A. So my first idea was to use 2 separate images for a total of 8 color channels using RGB and A for alpha. But the issue I ran into was that if I use the alpha channel for biome data and snap an image of that using the sub-viewport texture, any spots on the map where the alpha is 0, none of the other colors would get saved in the new image. Maybe it's a setting that I can enable, but I don't think it works that way. So we will do the next best thing and use 3 images using RGB in the first 2, and then we will just use red and green in the last biome image. So let's make some uniform variables so I can toggle this shader between displaying the biome colors to displaying the biome weights. So I'll do uniform bool display biome colors, and then uniform int biome weight image, and we'll set it to be the first biome image by default. So let's scroll back down to our fragment function right after where we calculated our blended color. Also, I just realized that all of this is inside this bracket and it's supposed to be here, so sorry about that. Still worked though, and you know what, I think it was looking weird before. There we go. Yeah, it was looking a little weird before, but now it's fixed. So I was supposed to be out of this original for loop when we started normalizing the weights. So I'm just going to go back to the bottom after we blended our color and right before we set the color.rgb. And I'm just going to make 3 new vector 3s for each of the images that we're going to save. So biome weights 0 is going to be the first 3 biomes, biome weights 1 will be the next 3, and then biome weights 2 will have the last 2 biomes, and then the green channel will just be 0. Then if display biome colors, then we will set color.rgb to blended color. There we go. Then else if biome weight image equals 0, then we will display biome weight 0. See that? And then else if biome weights. Biome weight image 1, biome weights 1. Biome weight image 2, biome weights 2. So now you can switch between our different biome images. So now we're going to want to capture these biome weights as images, but I want to do it all at the same time. So what I'll do is I'll make 2 more sub viewports by duplicating it, and then I'll duplicate the color rects and put them as children of the sub viewports. Then I'm going to make each of these shader materials unique so that I can edit them independently. So now I can have the first one be the first biome weight image, and then the second one will be the second biome weight image, and then the third one will be the third biome weight image. So now we need to make our biome generator script. And we will do the same thing by making references to all our sub viewports and our timer. And then we'll get our world configuration. Then we'll make empty variables for all 3 textures. So now in the ready function, we will set the texture size of all 3 viewports. Then we can go ahead and get all 3 textures. Then we'll bind the timer timeout signal to generate biome maps. And then we'll do timer.start. Let's make our generate biome maps function. So just like before, we will get the image from our textures and then generate an image texture from each image. Alright, and then we will make the paths for all 3 images. And then we can just save all 3 image textures like that. And then we'll print biome maps saved. We'll save that. Alright, so let's see what happens when we run it now. There we go, biome map saved. Let's take a look. There's the first one, second one, and the third. Alright, so now I'm going to show you guys how to use these images to get your biome weights at any given world position. So I'm just making a new scene. I'm just making a new script called test, and what I'm gonna want to do is preload all 3 of those images. And I'm gonna make empty variables for each image. So in the ready function, we'll do image1 equals biome1.get image. Image2 equals biome2.get image. Image3 equals biome3.get image. Now I'm just going to make a new function down here called get weights that will take your x and z world coordinates and will return an array with your biome weights. So we'll get our first set of weights from our first image as a color with image1.get pixel, and then our x and z coordinates. We'll do that for the other 2. Alright, now we'll make our array called weights. And we'll start assigning the 8 values of weights with weights1.r, weights1.g, weights1.b, weights2.r, then weights3.r, weights3.g, and then that's it. Then we are just going to return weights. Then in our ready function, we will just call the function getWeights with any integer value between 0 and the size of the image, which is 1024. So let's do 500, 700. And let's print the output. Gotta save the scene as tests. So here you can see we got our weights for that pixel. Let's try another one. 2 and 1000. So there we go. You can see that the last time we only had weights for 2 biomes, and here we have 3. But most of the time you're only going to see at any given point 1 biome having a weight, or 1 or 2, at most maybe 3 different biomes being blended together at once. And that's okay, you just don't want all of them to be blended at once. So there's your array of weights for that given point. So whatever your algorithm is for populating your world based on biomes, you can find the biome weights of any given point on your map by doing this. So that's pretty much it for this video. I'm going to get to work on the next steps for our procedural world generation, so I'll see you in the next video.